Turgeon here, bringing you physics from afar. Let me help you with the impulse momentum theorem. Kind of like the work kinetic energy theorem and kind of like Newton's second law, as I showed you in a previous slide. J represents impulse and P represents momentum. So yes, you should sort of think of them as being equal to each other. But more specifically, you want to think of them and write this down. I'm probably not going to technically require this, but write this down if you choose to, that you should think of the impulse as having given the object additional momentum. The change in velocity, we'll get to the change in velocity. So the way I like to write that is actually like this. Impulse is ft. You'll often see a delta in front of this for the change in time that occurred, but I think that's understood. T is just the time that passed while the force was being exerted. Now this delta V is just one quantity. It represents how much the velocity changed. Change in velocity. So if you think about it, a change in momentum, you could take the mass and multiply by the change in velocity. You could also think of it as mass times velocity final minus mass times velocity initial. But if you play that out completely, all the algebra, you're going to see it's the same thing I have here. Let me explain this problem and another one after this that's really tricky. So what we can see here is, given the information that I have, it makes sense that since I'm interested in a force and I have time, masses, and velocities, I'm going to get 545.5 newtons. But look at this. The change in velocity was -6 meters per second. If you think about it, he was going north at first and then he was going south. That's a change in velocity of -6 meters per second. It's a large change. Think of it as positive, think of it as final minus original. So final is -2 minus 4. If you're still having trouble thinking like, why is it not a change in velocity of 2? Think of it like this. What if we just said the football player was moving north and then comes to a complete stop? You'd have to agree that that was a pretty big change in velocity from 4 down to 0. How could it be less of a change of velocity if he goes from 4, not just to 0, but actually ends up going the other way at 2? It's a pretty big change. The impulse on the 100 kilogram player is simply the change in momentum. And the change in momentum is the mass times the change in velocity, so -600 Newton seconds. And there are other ways to do that as well. Let me show you another problem. This one's really tricky. What if we had a 1.3 kilogram tennis ball that's coming toward the ground. It's going to bounce off at the same angle, and it's making an angle of 70 degrees with respect to the horizontal. We want to know the impulse on this thing. Okay, again, here comes a tennis ball. Now, more realistically, we're talking about this moment followed by this moment. It's like right after that occurred, okay, the right before and after. But I'm just showing this to give you more of a sense of the incoming and outgoing velocities. But incoming, outgoing velocity is going to be the same. 2 meters per second, 70 degrees below horizontal. 2 meters per second, 70 degrees above horizontal. What was the impulse? Here's my answer. We only care about the y component. There's no change in the x component. Momentum is a vector, so it can be broken down into horizontal and vertical components. So my y component is 2 times the sine of 70 to get this piece literally right here, this vertical piece right here. 2 times the sine of 70, which is -1.88, negative because it's down. On the other hand, my final y velocity component is 1.88, and that's positive. You could find the original x components. Sure, let's do that. Let's use cosine. And the cosine of 70 times 2 is positive 0.68 because it's to the right in the beginning. It's also to the right at the end, so there's really no change in the horizontal velocity. The change in velocity vertically, though, was positive 3.76. Why was it positive? Because it went from negative to positive. Went from, think about it like money. If you go from negative $1.88, like you're $1.88 in debt, and then you have $1.88, you gained $3.76. So I'm going to plug into Ft equals m delta V. You get 4.9 Newton seconds upward. This is hard. Let me try to anticipate something that I know people struggle with. How did you know to break it down into components? That goes back to what I taught you in September, which is whenever you see any kind of a vector, you should have I almost said the impulse. You should have the compulsion to just habitually break it down into horizontal and vertical components, just like projectiles, just like forces. The other thing people say is, how do you know that it's only based on the y? And then if this was going off a wall, it would only be based on the x component. And they try to generalize and think of rules for that. Well, the only rule that I think you should really latch onto is this. There was only a change in velocity in the y direction. There was no change horizontally. Therefore, there's no impulse horizontally. This makes sense because the only force I can really identify here is that there's a normal force on the ball from the surface, which is directly upward. Okay, did you learn a facet of physics? Yeah, I think you did. I think the facet of physics that we're interested in here is related to what you might call problem type. You might call it choice of strategy. Facet of physics means a way of looking at physics. It means a way of doing things. It means, what do physics experts know? And what perspective do they have on physics that might be unique and that might help a novice learner? Now, this word novice, that's actually part of the research. People refer to beginners in a subject as novices. So the facet of physics here is one of choice. It's a decision. This is like, I imagine this decision tree where you have to decide, what kind of problem even is this? Is this energy? Is this force and acceleration? If you list what you know, which I didn't model very well, I could, but let me do it verbally. If I list what I know, I have M, I have V, I have T, and I'm asked for an F. Man, does that suggest Ft equals m delta v. So there's this intuition that comes with having enough of a background and practicing these different kinds of problems to know even what kind of problem am I looking at. Because something we take for granted when we're doing, if you're doing an energy quiz, you know you're going to use energy equations, and if you're doing a projectile quiz, you know you can do a projectile approach. But what do you do when you're taking the AP exam and you're not sure? So to that, I would say, yes, it comes through practice and repetition, but also it comes from building this mental model and from having a feeling, having like a gut, I'm not going to say it, having a gut sense about what impulse is, what energy is, what acceleration is, and the differences among them. This has been Physics from Afar.